What is your earliest memory of something being unfair? How did it feel when the teacher called on someone else, or when your parents treated your siblings differently? In this video, we will highlight a few different notions of fairness and how they relate to the theory of computing. Though many children develop a sense of what's fair or unfair, the topic of fairness has long been debated by legal scholars, philosophers, statisticians, and more recently, computer scientists. The notions of fairness we examine deal with different situations of discrimination, and understanding them is crucial to addressing bias in ourselves and the algorithms we build. One of the oldest notions of fairness comes from the legal principle that two people who are similarly situated should be treated the same. This gives us a definition of individual fairness, which is intuitively appealing but comes with inherent challenges. The definition of individual fairness can be used to prove discrimination in the context of hiring, where the same resume with different names may be screened differently. One of the challenges to achieving individual fairness is the difficult task of setting appropriate metrics to measure how similar two individuals are. It might be natural to say that two exact copies of the same resume with different names are similar, but what if they listed different schools, or different amounts of experience? At what point do two individuals become so different from one another that they can be treated differently without creating discrimination? Before answering these questions, let's examine some other notions of fairness. Group fairness encompasses many definitions, and we will look at just a few notions in this vast category. Before we dive into group fairness, let's go back to the legal system and look at the concept of protected traits. These traits include characteristics such as race, gender, and age, which are protected by law from acts of discrimination. Groups divided by these traits are called protected groups. Group fairness definitions often compare and equalize the average outcomes for different protected groups. By the notion of statistical parity, a decision-making model is fair if the percentage of a protected group that receives a positive outcome is similar to that of the general population. In addition to looking at a model's predicted outcomes, other definitions require us to look at the actual outcomes of individuals by attempting to balance the rates of false positives and false negatives. The notion of calibration examines whether a model is equally calibrated between protected groups by measuring how closely the model's predictions match the actual outcomes for members of different protected groups. Yet another notion of group fairness does away with protected traits altogether. Anti-classification, also known as fairness through blindness, achieves fairness by excluding protected traits from the model's input features. The notion of anti-classification may seem like a straightforward way of achieving fairness. However, it can lead to reduced accuracy as well as unseen biases through input features that are proxies of protected traits. Someone's zip code, for example, may be an excellent predictor of their race, so even if an algorithm does not have access to racial data, it may be making decisions based on the individual's race by proxy. As you can see, different notions of group fairness can help us uncover different situations of discrimination. Though some notions of fairness may seem simple to implement, the models that satisfy these notions may not be fair. These are just a few of the many definitions of fairness that people use today, and more sophisticated families of definitions have been developed in recent years. Fairness, like our society, is multifaceted and constantly evolving. Although each definition inevitably has its own weaknesses, it also augments our language for understanding and debating fairness. With the increasing impact of algorithms on our lives, this conversation around fairness is more important now than ever. We need to bring in scientists, scholars, and policymakers from even more communities to examine existing definitions of fairness, improve fairness-based algorithms, and create regulations that uphold our collective notions of fairness.